Okay, for this video, we'll be going through practical electricity success criteria I. Explain why switches, fuses, and circuit breakers are fitted to the live wire. Okay, so recall that live wire is actually at high potential. Okay, so of 240 volts. So if you were to come into contact with the live wire, and because your feet is on the ground, okay, and ground being at 0 volts, there will be a potential difference, right? And therefore the current will flow through you who is making the connection. Okay, so the live wire is actually very dangerous. So what does the switches do? Switches are designed to break or complete an electrical circuit. When it breaks, it's an open circuit. When it completes, it's a closed circuit, right? They should be fitted to the live wire. So similarly to fuses and circuit breaker, they are fitted into the live wire. Now, if the switch is connected to the neutral wire, the appliances becomes live and can create an electric shock when a person touches it, even when the switch is open. So let's take a look. Okay, we can also think of it as the fuse also in the neutral wire. But let's do the switch first. So in this case, we see that this is the live wire, and the live wire is brown in color, right? And it's at high potential, 240 volts. So this is a neutral wire, so it's at low potential, 0 volts, right? And let's not think about the earth wire first. Okay, so in this case, the fuse is connected correctly to the live wire. Okay, whereas the switch is connected incorrectly to the neutral wire. It should be actually in the live wire. So in this case, the switch is open, right? So basically, you see that the socket or some devices, they have a switch, right? And the switch is actually open or the appliances is off. However, the appliances is still connected to the live wire. Okay, so then, okay, so example, before the electrical fault, the heater is connected to the live wire. Okay, then when there's an electrical fault, so you have been using these appliances for a very long time. Okay, just that there wasn't any electrical fault, so that's why even though the switch is at the neutral wire, it is okay. But you never know when the electrical appliances will have an electrical fault, and in this case, one of the common electrical fault is that the live wire breaks loose, right? And it touches the metal casing. Okay, so maybe this is a water heater, so maybe it doesn't have a earth wire, but let's just take it that there's no earth wire. The live wire touches the metal casing, and this metal casing becomes live. Okay, so this is what it's saying in number 1. The live wire may become loose and comes into contact with the casing. Okay, and that results in the appliances casing to be at high potential because it's connected now directly. If you can see here, it's connected directly to the live wire, which is at high potential. Okay, so when the person happens to touch the metal casing or the casing of the appliances, right, it forms a closed circuit, right? A closed path may form, and therefore the current will flow through the live wire, through the casing and into the person, and it results in the person getting an electric shock. Okay, so where should the live wire where should the switch be connected? It should be connected to the live wire. Okay, so we see that the switch is open. That means the appliances is no longer connected to the high voltage, but it is still being connected to the neutral wire. But that is okay because neutral is at 0 volts. So even if the person touches it, the person being at 0 volts in the ground, touching the ground, there is no potential difference. Okay, so nothing will happen. And let's say now there's an electrical fault. Okay, the live wire touches the casing. Okay, and because there is this break in path over here, okay, there's now a break in path over here. Okay, so this part will not be at a high potential because there is no path with the switch open. So meaning to say, if the person happens to take this heater for repair with the switch open, right, it's an open circuit, it is very safe. Therefore, the fuse should always be connected to live wire. Okay, and what do we say? The switch on the live wire will disconnect the metal casing from the live wire when the switch is open, and this is what is happening over here. No current will flow through. Okay, so far we have done a few safety features. Let's do some recap, okay, or summary here. First one is the fuse. It's used in the socket plugs to prevent excessive current, because if you recall, if there is excessive current and it exceeds the fuse rating, right, the fuse melts, and then this creates an open circuit, right, and this will disconnect appliances from the high voltage. Okay, so our purpose in safety is always that we are not in contact, or the appliances is not in contact with the high voltage when there's an electrical fault. Okay, so this excessive current can be caused by the appliances having an electrical fault. Next one is circuit breaker. So it's used in distribution box again to prevent excessive current flowing. So the circuit breaker, instead of melting, it will trip when the current exceeds the working current. Okay. Then we have the earth metal casing. So this is to prevent the live wire from causing the metal casing to be at a high potential, right? So the live wire may become disconnected and touches the metal casing, but because there's an earth wire, this earth wire is actually, we have earth wire. This earth wire is actually at a very low resistance. Okay, meaning to say that the current will flow through this earth wire instead of someone who accidentally touches the appliances that has electrical fault. So double insulation is very simple. It's to prevent contact with the live wire. So remember, the symbol is this. Okay, and this is usually for appliances with plastic case. Okay, plastic cases. Okay, and we have 2-pin plugs only. There isn't any earth wire. There's no need for earth wire. So basically, I will save on the material as well. So that's why, if can, the appliances made of plastic, I'll just use a 2-pin plug, double insulation. Next is the earth wire, which is actually a wire of very low resistance. Is basically to earth the metal casing. Okay, so the next video will be on the practice questions.